Suppose we wish to analyze this beam, using the displacement method. The indeterminate beam is subjected to a uniformly distributed load. We can start by replacing the load with its equivalent, joint loads. To determine the joint loads, we calculate the fixed end forces for a beam segment subjected to a uniformly distributed load. Since both beam segments have the same length and are subjected to the same load, they are going to have identical fixed end forces.
We reverse the direction of the forces and place them at the joints. Note that in joint B, there is no bending moment, since the moments at the ends of the two beam segments cancel each other out. So, we get these equivalent joint loads. But, we are not going to use all of them. We use the ones associated with the degrees of freedom of the system. The beam has 3 degrees of freedom. Rotation at B, vertical displacement at C, and rotation at C. The corresponding joint loads, then, are
Now, we can write the system of equations having the displacement vector as its unknown. To determine the coefficients of the system stiffness matrix, we need to write member stiffness matrices. Both members have the same stiffness matrix. Now we are going to assemble the system stiffness coefficients from member stiffness coefficients. That gives us this system of equations. We solve it for the unknown displacements. Knowing the member end displacements, we can now write the member end forces for each beam segment.
For segment AB, we get For segment BC, we get We are now ready to calculate the support reactions, like this.